An ELISA test is used to determine whether a certain autoantibody is present in a serum sample, as well as its concentration. In autoimmune diagnostics, commercially available test kits containing all the materials and reagents required are usually used. Prepared kits can be stored for a fairly long time in a refrigerator. Before use, the kit should be taken out of the refrigerator and all reagents and samples should be kept at room temperature for 30 minutes. Each kit contains reference samples with defined antibody concentrations for preparation of a standard series, as well as negative and positive controls. Conjugate, substrate and stop solution are ready to use. The sample buffer and the wash buffer are delivered as concentrates and must be diluted to the right end concentration before use. 20 milliliters of wash buffer concentrate are thus diluted to an end volume of 1 litre with distilled water. 20 milliliters of sample buffer are diluted to 100 milliliters. To obtain values within the range of the standard curve for proper evaluation, the serum samples must also be diluted in a 1:100 ratio with the sample buffer. The sample dilutions should be freshly prepared for every test. 10 microliters of the serum sample are prepared and 1 milliliter of sample buffer is added by pipette. The samples are then thoroughly mixed. The microtiter plate is removed from its protective cover. This is the core of the ELISA test. The wells of this microtiter plate are coated with a specific antigen targeted and bound by the antibodies being detected. The microtiter plate consists of individual strips that can be used as needed. The number of strips required for a given test run are set into the frame. Leftover strips can be returned to the protective cover and stored in the refrigerator for later use. The standard series, controls and samples are now pipetted into the plate according to the corresponding pipette diagram. Standard solutions A through F contain antibodies at defined concentrations. The negative control contains no antibodies. The positive control always gives a clear colour response when the test is carried out correctly. To avoid cross-contamination, the samples and controls must always be pipetted with fresh pipette tips. As an internal control, all tests are carried out in duplicate. Standards, controls and samples are each pipetted into 2 wells. As far as possible, all reagents and samples should be pipetted to the bottom of the wells. Autoantibodies present in the serum samples can bind to the antigen that is immobilized on the plate. This occurs during the first incubation, which takes 30 minutes. To remove unbound antibodies and other components of the sample, the plate is washed 3 times with 300 microliters of wash buffer per well in the ELISA washer. To remove residual wash buffer, the plate is firmly tapped several times. An enzyme-linked secondary antibody is then introduced, such as anti-immunoglobulin G antibody, covalently bound to the enzyme horseradish peroxidase. This conjugate reacts with the antibodies from the serum sample. This forms a complex of the immobilized antigen, autoantibody and marked detection antibody. The next step is incubation for 15 minutes. This allows the conjugate antibodies to bind to the autoantibodies fixed to the plate. The wells are then washed again to remove all unbound antibodies. Next, 100 microliters of the substrate solution is pipetted into each of the wells. The substrate is 3,3'5'5' tetramethylbenzidine, which is converted to a blue pigment by the peroxidase. After a short time it is possible to see the different intensities of blue in the various wells with the naked eye. This reaction is also complete within 15 minutes. Addition of phosphoric acid stops the reaction. The colour changes from blue to yellow. The intensity of the yellow colour of the individual samples is measured by a plate photometer at a wavelength of 450 nanometers and recorded graphically. With the aid of the standard curve obtained in the test, the concentration of antibodies in the unknown serum samples can be quantitatively determined.